so let's take a look at part 4. Okay? First of all, let's take a look at what it says you have to know. What you have to know according to the curriculum is now this idea of multiplication involving polynomials. I know it says division there too, but we're going to look at that in part 5. So today we're just going to focus on multiplication, and you need to be able to do this both symbolically using the math that's a little more traditional and pictorially using algebra tiles, and I'll show you both of those methods. Okay, quiet down please. Okay, so first let's start with two monomials. First of all, how many terms are in a monomial? 1, right. If it's 2, what's it called? Simon? Binomial, right. Binomial is 2. Okay, so this is the simplest one, okay? But sometimes the variables are going to be different. So for example, a times b, you can't make it into like 2a or a squared. It can only be combined as a times b. Okay? Shh. Similarly, in this example, I'm multiplying negative 3 times 5xy. The negative 3 is multiplying by the 5 to give us negative 15xy. We looked a little bit at this in part 1. Today we're going to dive a little bit deeper. Okay? In the third example, you see 2m times 3n. Be careful when multiplying these two together. The m and the n cannot be combined. So they're just going to be mn. But the 2 can be multiplied by the 3 to give you 6. Okay. This should not be revolutionarily new to you. But now let's kick it up a notch. We're now going to multiply a monomial with a polynomial. Okay, here's the process. The process going on here is called the distributive property. To distribute something means to hand it out, right? If I distributed you guys candy, I'd give you all a piece of candy. I'm distributing candy to you guys. This is very topical being Halloween today, okay? The idea in math is when we are distributing it, we are multiplying the first expression by everything in the second expression. You have to multiply it by everything. Sort of like everyone gets a candy, so everybody gets multiplied. Let me demonstrate, okay? The traditional way it's written is this. 2a plus b equals ab plus ac. But for a lot of you that might be confusing, so let me put it to you this way. In this example, I'm going to multiply 2x by everything in the brackets. How many terms are in the brackets? Okay, just take a look, just yell it out. How many?
3.
Remember, you could use a cut system to cut it into 3 parts. Y is a term, negative 2z is a term, and 5 is a term. So, 2x has to be multiplied by all 3 terms. Watch as I do this. 2x times y is 2xy. 2x times negative 2z is negative 4xz. And 2x times 5, what is it? Anyone? What?
10x.
10x, that's right. Okay? So this becomes my new expression. These 3 pieces put together gives me 10x plus 2xy minus 4xz. Now this is, what we're dealing with here is we're multiplying this thing by everything inside it. We're distributing it amongst it. Simon? You can't. That's why it becomes xz. You can't combine them. The coefficients, yes, you can combine those, right? Because you can multiply 2 times 5, but you exactly are right. You can't multiply x times z, so it just remains x times z. Okay, good point. Okay, let's do a couple more examples. Okay, here's one. Now this one is a little bit simpler, but here you can see distribution happening, or the distributive property. So 2 times x and 2 times negative 3y. And then negative 3 times 5x, negative 3 times negative y. So start to think about what the answers are going to be. What's 2 times x? 2x. What's 2 times negative 3y? 6y. Right. What's negative 3 times 5x? Negative 15x. Watch this one. What's negative 3 times negative y? Say the sign. Positive 3y. Negative times a negative equals a positive. You guys are getting this. Now from here, we can still do our combined like terms. There are some stuff in there that we can combine together to make that simpler. Okay? So the idea is, this is a complex expression. This is a simpler expression. If now I told you x is 2 and y is 3, you'd have a much easier job solving this than solving this one. Okay? So the idea is we are simplifying the algebra a little bit. Let's try another one. Okay? So 4x times x minus 3 and negative 2 times x plus 3. Now in this one we're going to see something interesting happening. And really think about your answer. What's 4x times x?
4x.
No, not 4x. Not 5x. Good. Not 6x. Tynan? Not 8x. No, not 4. Just stop for a sec. Stop for a sec. Forget the 4. What's another way of writing x times x? 2x. No. X squared. What's 4x times x? 4x squared. Okay? Okay, we just kicked it up a notch. It's getting a little harder. Okay? Now in here I can still combine like terms, right? 12x negative 2 becomes negative 14x. Okay, you can see this can get complicated fast, but don't worry, we're going to practice, okay? Let's try this one. Wow, now we got an x squared right in the equation, okay? But that doesn't necessarily make it harder. What's 2 times 3x squared?
6x squared.
You got it, 6x squared, okay? What's this one? What's negative 2x times x? Negative 2x squared, that's right. Okay, so the second time you did it, it became a little easier. Good. From here, now look, I can combine that 6x squared with that 2x squared to create 4x squared. Okay? Terms that are squared are considered like terms. So that 6x squared is like the negative 2x squared. Okay. What I now want to introduce is that thing called the distributive property now becomes part of part 1. The one that we've been always skipping, that's now where it comes into play. Because in part 1, you are removing the brackets by using the distributive property. Okay? So in harder questions, that's now where it comes into play. So it's the same steps we've been working on for 2 weeks now, but now with multiplication, we add it into step 1. Okay? So it's just it's added on to the stuff we've already done. Okay, here's how we do it in tiles. Okay? To be honest, this actually is an easier way for a lot of kids. The tile thing actually does make life a little bit easier for multiplication. And I'll show you what I mean by that. Okay? So you guys know that the way tiles are drawn, okay? But when you have two different variables, x and y, how do you draw those as tiles? Well, usually they just draw them as different colors. So you can say, well, those are the x tiles, and those are the y tiles, okay? This is obviously something you can't do on a math test because they're not expecting you to have a whole bunch of markers and coloring and stuff like that. But on a question, you might see something like that. So that shows you that you can't combine the blue and the black. They're different tiles, okay? Negatives and negatives. Again, harder to draw, but just different colors might work. Another way, other than colors, is to actually write the letter inside. That also makes sense. Okay. To represent multiplication using tiles, what you're going to draw is a giant rectangle. Here's the process, okay? If you have something like this, 2x times 3y, you represent those as different sides of a rectangle. please watch and I'll show you how to do this. 2x is drawn right here. 3y is drawn right here. And then basically you just draw a grid to fit it. And you get your answer in the middle. The answer is 1, 2, 3, 4, 5, 6 xy. And that's the answer, 6xy. It's a little confusing. This is also explained fairly well in your textbook, but let's take a look at another example, okay? So, here's another one. I'm going to multiply 2 times x minus 2 using tiles. First thing I'm going to draw is x minus 2. There it is. Next thing I'm going to draw is 2. To draw 2, I just draw this, 2 singles. Create a grid. Fill in the grid. When you fill in negatives into a grid, the negatives go all the way down or all the way across. And so now I get this. I get my answer. My answer is 2x minus 4. I'm done. Okay? It's a bit tricky. You're going to have to practice it. But in reality, it is actually a fairly easy way. Guys, please don't come to class if you're going to be so rude. Just stay home. It's Halloween. Go trick-or-treating now. Okay? Okay, shh. All right. Let's take a look at one sort of more example. Okay? Here's the steps. Step 1. You have this thing, x plus 3 times x plus 3. Okay? How am I going to represent this with tiles? Well, step 1, draw a term on one side of a rectangle. So, okay, I know I'm going to make a rectangle. So here's x plus 3. Here's x plus 3. I then use those shapes to create a grid. So in other words, I'm taking the shapes and drawing grid lines. So I'll do that now. Here come the grid lines. Grid lines that way, grid lines that way. And then all I do is inside the grid, fill in the shapes that would be in there. So that shape would be an x squared tile. These would be a bunch of x tiles. These would be a bunch of x tiles. And these would be a bunch of 1 tiles. And then I just count. I have x squared and 1, 2, 3, 4, 6 x's. And how many is that? Looks like 9. And that's my answer. My answer is x squared plus 6x plus 9. So the tiles can actually be used to solve these problems. Because if I asked you to solve this, that might be a bit hard. But using the tiles actually can give you a solution there. You're going to practice it. I'm going to really suggest you read what it shows in the textbook on this as well. Because, I mean, I could keep doing examples, but I'm not sure if that'll really get it across to you until you try it yourself. Okay, here's one more. Okay? So with this one, we're going to do the same thing. We're going to draw squares. We're going to draw the tiles there. We're going to draw the tiles there. Now, the only difference with this one is when you have negative tiles, they always go all the way down or all the way across. So whatever tiles I'm going to draw in here will be negatives. And now I just count them up. X squared minus 2x plus 3x. Wait a minute. Can I cancel some of those? Sure I can. These two can cancel those two. So really I only have 1. X squared plus x minus 6. And I'm done. Okay? So the tiles can be useful to you. Again, showing it to you this way isn't going to really work for you. You're going to have to actually try this to really get a feel for it. Okay? One last one. Do it quickly. There's the tiles. There's the tiles. Fill in the middle. Count it up. Watch for ones that might cancel each other out. I get a solution. Okay. What you're about to see is bonus. So for those of you who are going into pre-cal next year, or intend to, you're going to hear the word I'm about to say frequently. It's another memory device. You guys remember BedMoss? This is like that, okay? When you do this without tiles, the way it works is you multiply everything in this thing by everything in this thing. How many multiplications will that be? Not 2, 4. There's 4 things. Okay? That times that, that times that, that times that, and that times that. 4 different multiplications. From there, you can simplify. But the way to remember it, the mnemonic memory device I'm about to introduce you, and that's the word, is called FOIL. FOIL, just remember that one word. It stands for first terms, outside terms, inside terms, last terms. Again, if this is confusing to you, worry not. This is bonus material. This is for those of you going into grade 10 pre-cal. Watch as I do this to the example. So what do? FOIL, first terms. Well, there's the first two terms, x and x. Those are the first two, x squared. What's the next letter in FOIL? O stands for outside two terms, which is x times negative 3. Gives me negative 3x. What's after O? Shh. No, FOIL is F-O-I. I stands for inside terms. 3 times x, 3x. And L stands for the last terms. 3 times 3, negative 9. Okay? This is called FOIL. Watch as I go quickly through this example with FOIL. First term, outside terms, inside terms, last terms. Gives me this. Simplify it down, I get this. Let's try it again. FOIL. Okay? Now, notice how this one was, again, a little more complicated. X plus 3 squared. Okay? So the algebra gets more complicated. To take it even one more step up on bonus, you can actually multiply a binomial by a trinomial, which you're about to see right here. Binomial times a trinomial. Watch how complicated that one gets in multiplication. Gets complicated. Okay? Worry not. It's not part of your grade 9 curriculum. That's why the word bonus appears here. Okay, so don't worry about the bonus. I'm going to just blaze through these last few examples. Okay? These will be in your notes. So you have these if necessary. These are complicated examples, so you can see they are a little more tricky. Okay? Here's one that uses a shape to find the area. So area means length times width. So this times this, and I can do it with tiles, and I get an answer. Okay? Here's another example. You can see here, gets complicated. So let's work that through. I get the answer. Okay? Again, I don't want to spend the time going through this. I can tell you guys would like to get to work. Okay? Same thing. I could use FOIL on this one to solve it, or use algebra tiles. All right, one final problem. A word problem. Here it is. Rich. That's to get your attention. I need to fertilize my lawn. This is the shape of my lawn. Here are the dimensions of my lawn. How much fertilizer do I buy? It's a crazy example, but it could apply. In order to figure it out, I'd have to determine the area of this shape and then solve it knowing that x equals 5. The way I would do it would be through algebra. Now, I'm not going to go through this step by step. We don't have time for that. Well, we do have time, but I'm not going to. But in doing this problem, you can use the tools I've given you in algebra, okay? Building those tools together and then plugging the answer in at the end would eventually give you, look how much simpler that equation is to the whole thing, okay? Once I have that, I can plug in the value of x and get my answer, okay? But you gotta kind of know the steps and the tools for doing this. So in summation, okay, basically I have a very simple small set of notes for you today. It's about the distributive property and how you distribute by multiplication the term through the other terms, okay? You will add this to step 1 of your inverse operations method that we've been working on. And when you want to do tiles, this is the step right there, okay? Any questions? Today's assignment will have you focus a little bit on that. I cannot strongly suggest as well that you also do the